Hello and welcome, my dear grade 9 elite and 10 advanced students, to my session on parallelograms, lesson 2.2. Today's session, we are going to look into some problems on parallelograms and use the theorems for solving the questions. So let's get started and look at today's goals. Today's goals would be to prove and use theorems about the properties of parallelograms and to prove and use theorems about the diagonals of the parallelogram. A vocabulary word would be parallelogram, and as you see, the word parallelogram comes from the word parallel. That means it's a figure having parallel sides. So parallelogram is a four-sided closed figure or polygon with parallel sides. So the opposite sides are going to be equal and parallel in a parallelogram. As you see, the definition of a parallelogram is that it's a quadrilateral. Quadrilateral means four sides with both pairs of opposite sides parallel. So it's coming from the word parallel. So you will remember that the opposite sides are parallel. So here AD is parallel to BC. That's how you write it. And AB is parallel to CD. Okay, so by the definition of the parallelogram, you have these things. The symbol for a parallelogram is this one, which is like a closed parallel quadrilateral that you can make. So parallelogram ABCD, BC is parallel to AD, AB is parallel to DC. There are also a few other properties of parallelograms that we are going to do in the form of a theorem. This is an important lesson, so stay focused and watch the video till the end. So the following theorems, we are going to do four of them. Number one, if a quadrilateral is a parallelogram, then the opposite sides are congruent. That means they have the same measure. That means if you have a parallelogram like this, A, B, C, D, then if this is 5, this is 5. If this is 3, this is 3. The measures are going to be equal. So you can mark it in this way. So the opposite sides are congruent or same measure. Second theorem, if a quadrilateral is a parallelogram, that opposite angles are congruent. So the opposite angles are going to be same as well. So if this is 70 degrees, this is also 70 degrees. And if this is 50 degrees, this is also 50 degrees. So they are like that. Then if a quadrilateral is a parallelogram, then consecutive angles are supplementary. Consecutive angles means angles which are one after the other. So if I make a parallelogram here, look here very carefully. This parallelogram, this angle is 110, then the other angle would be 70 degrees. Their sum 110 plus 70 would give you 180 degrees. So they are supplementary. Supplementary means their sum is 180 degrees. Okay, so the consecutive angles are going to be supplementary. Similarly, this is 70, this is 110. So this also will be giving you supplementary pair of angles. Next is, if a parallelogram has one right angle, then it has all four right angles. And this is quite true, because if you see a parallelogram like this is 90 degree, then the angles have to be supplementary. So this is 90. Opposite angles are going to be equal. So this is also 90 and this is also 90. So if one angle is right angle or 90 degree, then all four are equal. In fact, in the lessons to come, you will see that this parallelogram has a special name which is called rectangle. So the parallelogram actually becomes a rectangle if all angles are 90. Solve this question. So this is a parallelogram given to you, D, E, F, G. This is a parallelogram. How do you write it? You write parallel first and then OGRAM. It's a parallelogram. So you have to find the measure of angle D. Now measure of angle F is given, and angle D and F, as you see, are opposite angles. So they are going to be equal by the theorem. So both of them are going to be 106 degrees. So here the answer is 106. Now you have to find FG. FG is the opposite side to DE. Both are equal. So this is also going to be 8 inches. So the answer here is 8. If I may ask you another question, how much is DG? What will be your answer? Yes, you are correct. 3.6 is the correct answer, 3.6 inches, because that is going to be equal to EF, the opposite side of the parallelogram. Now we are going to learn about theorems related to diagonals of a parallelogram. You already know what are diagonals, but they have some special properties. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Bisect means they divide into two equal parts. Bi means two. So they are dividing or intersecting at two equal parts. So if the whole diagonal is 10 centimeter, then each part of them will be 5 and 5. So they are bisected for a parallelogram. So I will draw here. This is a parallelogram. And if you have the non-consecutive vertices like A and D, sorry, A and C, these are non-consecutive opposite vertices. You connect them with the diagonal, then AC is a diagonal of the parallelogram. Then this diagonal bisect each other. Can you draw another diagonal? And as you see, this diagonal divides into if I read the theorem 2.8, if the quadrilateral is a parallelogram, the diagonal separates the parallelogram into two congruent triangles. So this one, triangle ABC, is congruent to triangle ADC. This is going to be true, and this diagonal is dividing it into same area of the two triangles. If I draw the other diagonal, BD, then this is the point of intersection O, then AC is equal to OC and OD is equal to B. This is what is meant by diagonal bisecting. I will write here for you AO equal to OC and OB equal to OD. So both parts are going to be equal. Very important theorems about diagonals of parallelogram. Let's solve some questions on them. Okay, so let's solve this question together. Here you are given a parallelogram PQRS. PQRS, as you can see, angle Q is given to you, angle R you need to find. So let this angle Q plus angle R, we are using the theorem that consecutive angles of a parallelogram are supplementary. So this is going to be 180 degrees. Okay, so angle Q is 128. Let's put the value. Angle R we don't know, we have to find, and this is 180. So we know that the measure of the angle R that we need to find will be 180 degree minus 128 degree. So this is going to come out as 52 degrees. So the measure of angle R is 52 degrees. Now measure of angle S, also in fourth part it is asked. So opposite angles of a parallelogram are equal. So this is going to be also 128 degree. This is 52 degree, and if you ask, angle P will be opposite angle or it will be supplementary. So this is also going to be 52 degrees. Now QR is equal to PS. Opposite sides of a parallelogram are equal. So this is also going to be 3. And opposite sides of a parallelogram are equal, so RS is going to be equal to QP, so this is going to be 5. So we have got all the values. So which theorems we used? We used the theorem that consecutive angles of a parallelogram are supplementary. Supplementary means when you add them, their sum is going to be 180 degrees. Then we use the theorem that opposite angles of a parallelogram, I'm writing in short, this is how you write parallelogram in short, the parallel lines and gram are equal. We used that for getting F. Also, we use the theorem that opposite sides of a parallelogram are equal. We used this to get our value of QR and QP. So this is how you do the question. Okay, let's do some. Now here you are given in question 9 a parallelogram. You have to find the value of the variable x and y. Now, if you see carefully, this side is given 10, so this side would also be 10. This is 11, so this is 11. Which theorem we have used? We have used that diagonals of a parallelogram bisect each other. So when they bisect at this point. So this one, if I name it as P, then BP is equal to PD. So BP is given to be 11, PD is given to be x plus 6. So from here you can get x, move 6 to the other side, 11 minus 6, so x is 5. You have got the value of the variable. Then we have used the same theorem that diagonals of a parallelogram bisect each other, means this is equal to this also, this is equal to this also. So AP is equal to PC, AP is given to be 10, PC is given to be y minus 7. So now you move the 7 on the other side, so y is equal to 10 plus 7, so y is 17. That's how you get your answer. This one is very simple. You know opposite sides of a parallelogram are equal, so this is equal to this and this side is equal to this side. So a plus 15 is equal to 3a plus 11 and 3b plus 5 is equal to b plus 11. Now you can solve it. Take the like term here. I move 11 on the other side, it becomes minus 11. I move a on the other side, it becomes minus a. So 2a is 4, so divide by 2, a is 2 here. So that's the variable. Let's find b. B like terms, we move here. So 3b minus b is equal to 11 minus 5. You change the sign. 2b is equal to 6. So b is 3. That's how you find the variable. And the theorem that we have used for this question is this. And the theorem we've used for this question is opposite sides are equal. Let's solve question 11. For question 11, we are going to use the theorem that consecutive angles of a parallelogram are equal. Sorry, they are supplementary. So if they are supplementary, the sum is going to be 180. So let's do that. Angle H and angle G, they are supplementary. So sum of them is 180 degree. So I take angle G x minus 5, I take angle H 2x plus 11 and put the sum as 180 degree. Now collect the like terms. These x will go with 2x to give you 3x. 5 minus 5 will go with 11 to give you plus 6. So this is going to be equal to 180 degree. 3x is going to be equal to 180 minus 6 degrees. So this is going to be 174 degrees. That is 3x. So you need x. That means you are going to divide by 3. So 174 divided by 3 is going to give you 58. So x is 58 degrees. You have got x. So now you can get y. This angle and this angle are going to be equal because opposite angles of parallelogram are equal. This is the theorem we are applying. So 2y is going to be 2x plus 11. Let's find this value. We substitute 58 degrees, which is the value of x. Now 58 multiplied with 2 is 116 plus 11 is 127. So 127 is the value of 2y. So y would be 127 divided by 2. So here you are going to get a decimal. So 127 divided by 2 is going to give you 63. So that's how you get the value of x and y in the question. Similarly, you do question 12, use the theorem that diagonals bisect each other. So you will be using the concept that this and this side is equal, this side and this side is equal. Find y and z and let me know in the comment section what is your answer for question 12. Until then, this is Ms. Ruchika signing off from today's session of parallelograms. If you found the video useful, give it a thumbs up. Like, share and subscribe to my channel and see you in my next video. Bye students.